All right, welcome back everyone to another live stream from the ATL Bit Lab Battle of the Mind Hackers. Let's see, just getting things situated here. And I'm adding Ragav to the stage. Ragav is from Proto and one of our judges. Welcome. And I'm going to get my screen shared here and we can kick things off. So let's see, which screen do I want to share? Stop that one. I'm going to present, let's see. All right. So let's go ahead and kick things off. If there's any issues hearing, any audio issues, please let me know in the chat and we'll get it taken care of. If you have any questions or comments throughout, feel free to drop them in the chat. So broadcasting live from ATL Bit Lab. This is a community space in Atlanta, Georgia for Bitcoin and freedom technology. If you're interested in a place to work with other like-minded people, let us know. Especially if you live here, if you're just visiting us in Atlanta, let us know. We'd love to hear from you. We are putting on our first hackathon. This has been going on for about a month, and this is our final stream for this event. And so this is the Battle of the Mind Hackers. This is a month-long hackathon that is focused on Bitcoin mining decentralization. We've noticed an interest in our own community as well as at other Bitcoin meetups around the world with Bitcoin mining. It's a topic that fascinates people and excites people, especially new people coming to the meetup. We wanted to try and take some of this excitement around Bitcoin mining and encourage people to get working on projects that would help decentralize Bitcoin mining. That's stuff like open source hardware, open source firmware, novel uses of energy, software decentralization protocols, all that good stuff. So this has been going on for a month now, and we're really impressed with the results here and happy to show that off. So today, what we are looking at is the finalist presentation and award ceremonies. Before we go any further, I want to go ahead and thank our sponsors, CleanSpark, Pleb Lab, Human Rights Foundation, Hash League, 256 Foundation, Bitcoin Park, Choya Inc., and Cryobyte. We wouldn't be able to do this without the support of all of you. These are organizations stepped up to provide money and funding to make this event possible, as well as resources and assets to make this event much better. So we have three tracks, prize tracks for this hackathon. One is the software track. This is working on stuff like Stratum v2, hash pool, software level decentralization tactics. We have a hardware track. This is for working on open source mining systems, all that good stuff. And then there's an energy track. These are novel uses of energy, finding ways to reuse the heat out of miners, heat punk style stuff. So there's the same prize for all of these, 1.5 million sats, a year of ATL BitLab Social Pass, and a Cryobyte S19J Pro cooling kit. We also had a Hash League sponsored challenge for the best new addition to Hash League, as well as a 256 Foundation sponsorship or Bitcoin Park membership for 1 year. That's the best use of 256 Foundation technology. So we've got several of our finalists on the call today to present their work to you live. Now, I'm going to, real quick before we get into our finalists, I want to go over some honorable mentions real quick. So those are people who, were not finalists, are not going to win a prize, but I just wanted to be able to highlight the work that they put in. These projects are Cambio, Travis's hot water heater, and Dane's water heater. So let me go ahead and switch and share something different. I want to quickly highlight these projects. Well, Cambio, I can go over right quick here. So this project was essentially a Google Doc for a remote Bitcoin mining controller. And, this is just a Google Doc. It's not working code or anything like that. But the reason I wanted to highlight this project is that I was really happy that they submitted it even though they didn't have time to build it. This was an idea. I think they hacked with some code originally and just kind of ran out of time. And life gets in the way sometimes, right? And you don't always have time to complete the side projects you set out to do. But I'm really happy that they drafted up their idea, put it in a Google document for everyone to review. I think this is just an important part of working in open source, is to not be afraid to share the work you're doing. It's really easy sometimes to get in your head and not submit something or not share your work because you feel like it's incomplete. And I think it's fun and valuable to share what you're working on, even when you feel that it's not complete, because that's how you can get other people excited about your project. It's how you can get feedback on your project, all of that. So thanks for submitting, even though it's just a Google Doc. I also want to highlight Travis and Dane's water heater. And if you give me just one moment, I need to reshare this because I need to set this up in a way to where you can actually hear it. So give me just one moment. I'm going to present a tab, Travis hot water heater. Thanks for the comments in the chat, everybody. All right, so let me just double check and make sure I shared that with audio turned on. Share screen, tab, Travis hot water heater, also share tab audio. Okay, cool. So I'm going to play the video that Travis submitted here. This was kind of a late submission, but I'm glad that they submitted it anyways, because they definitely have been putting some work in. And if there's any audio issues, please just let us know in the chat. We'll get it figured out. Ooh, let me see if I can turn on captions. Nope. Okay. Never mind.
Okay, my apologies for being behind on this, but I built a Bitcoin water heater. I thought I had till July 14th, but I guess submissions are due right now. And I've got an M64 miner that is powering or heating a indirect water heater right now. And what we have here is basically we've married a hydronic system together with a domestic hot water. So right now I've got this set up as a primary and secondary loop. Here's the primary pump. And right now the M64 is making about 160 degree water. The return is 140 degrees Fahrenheit. And I had to try a couple of different iterations of this. The first iteration had zone valves to feed hot water to the jacket around the water heater here. And the zone valves were powered by turned on by the aquastat, the thermostat on the indirect water heater. Well, what I found was that the zone valves would close and the pump would deadhead for a little while, and then the miner would go into error and either stop or reboot or something like that. I changed the configuration so that we have a primary loop, and then this goes out to a cast iron radiator in my garage, and a secondary loop. And then here you can see the secondary loop with another pump that is run by this controller and the aquastat on the water heater. So whenever the water heater calls for hot water, because 160 degree water is too hot for domestic hot water, this pump will turn on and then circulate hot water through the water heater and then push it right back into the supply side. That goes out to the garage to the water heater the cast iron radiator that's out there, and that returns right here and then goes back up and back into the miner. So the first iteration didn't work so well. Right now I'm running on this maybe a couple of weeks, and I apologize for the late submission. And but it works great. It's Bitcoin hot water. I love it.
All right, Bitcoin hot water. I love it too. We also had another submission, another kind of late submission from another hot water project. Let me go ahead and find that one, find the appropriate tab. Let's see. Okay, and I'll be honest, I'm a little there. This one was kind of submitted to us as multiple videos, and I'm a little not sure how all of this fits together, to be honest. So I'm just going to start with the first one and play them all. I might skip around a little bit here because they're, you know, these go into different parts and it gets a little lengthy. But I just want to go ahead and highlight some of what this Dane person is working on.
Hi, this is Dane Joden, CEO and founder of Hashrate House. I wanted to give you guys kind of a run through of our 2 miner system here. This has been in the market for about 2 years, been getting some really good feedback on it and really overall positive experiences with it all, and focusing mainly on the idea of immersion mining at home, but really focused on heat reuse and being able to capture that heat and use in beneficial ways. This one, like I said, has had a couple design feature changes. New and improved smart PDU with remote switching. It's actually going to have 2 NEMA 5 or 1450 plugs coming out, which is a super high power, mainly focused. So the idea that you could go to the hardware store and DIY that side of it, get your electrician can do it. It's a lot cheaper wiring to get 50 amp wire. And what it would do is it's going to run, each plug's going to run 2 of these, because right now I currently have one of these deployed in the northern states, cheaper electricity with the Ardyne AL 3680s, and those have super feature rich firmware and ability to they're clocking 390 terahash, and each one takes a fully loaded C20 plug. So you need effectively 100 amps to run 2 in here, but that makes one box be able to put out 10, over 10 kilowatts, almost 14 kilowatts of heat or of power out of just 2 miners. So that's why I focus mainly on being able to have 2 50 amp plugs coming out. But if you don't want that much power and you're just running S19s, S21s of the likes, you can actually just plug in one of them and that will run all the peripherals, the pump, the network, integrated network switch, all the controls, all that, and enough plugs to do 2 S19s or S21s. So you kind of have a modularity there on being able to expand and revamp it. So it's kind of basic immersion box, but you know, obviously all the stuff in it is all the CFD and design that's really come into making it be able to flow and capture the heat most effectively. Locking lids, super important. It's waterproof, so you actually could put it outside if you wanted to. Leveling casters on your feet, so you know, if it's on uneven ground or whatever, it would be fine. This is kind of our 2 miner system has been our, like I said, kind of bread and butter to start off and what really got us stood up here. And this is a revamp of the whole deal and has been working great. I apologize, I'd be showing you in real life. You can go on the website if you want, hashratehouse.com, look at it there. But kind of doing a rebranding and a re-website design. So this is just a quick recap of the 2 miner, and I'll give you a show of the 4 miner here is our new one too.
Okay, so I think that was like a project that they've been working on already as part of their company, which is also valid. You can also submit projects that you were already working on before the hackathon. You just need to let us know what you did before the event and what you did after. All right, cool. Let me go ahead and check my notes. I think that's all the honorable mentions we need to get through. So now we can start looking at our actual finalists here. So I think to kick things off, we're going to look at the Bitcoin mining air conditioner. I'm going to add Rev Hodl to the stage here. And if you give me a moment, I'm just also going to pull up your video submission and get that shared so that we can start playing that. Let's see. Okay, so we have this video here. And I'm going to share this. Let's see, what's it called? There we go. Bitcoin mining air conditioner proof of concept. Rev, I'm not going to share the tab. I'm not going to share the audio since you said you wanted to narrate over this. Can you? How's it going, Rev?
Hey, yeah, excited to be here.
All right, I've got this pulled up on screen, and let me just full screen that. And whenever you're ready, I'll kick it up and play it.
Yeah, I'll let you know when to play it. I guess I can talk a little bit about the submission and the idea before we watch the video here. I've been toying around. So first of all, the heat reuse with Bitcoin miners is typically in the examples we've seen prior, utilizing the heat to heat hot water, heat your house, actually heat things. But a lot of people live in southern climates, live in areas where they don't get access to the heat they don't get these cold winters where they can get that low hanging fruit of using a Bitcoin miner to heat their home. But everybody in those areas typically wants an air conditioner, a way to cool a space or dehumidify a space. And I'd been thinking about ways to easily apply this concept of using the heat and the airflow from a Bitcoin miner to actually create a cooling effect in an interior space and add some dehumidification. Now, this submission is basically the first attempt at my concept here, which is basically utilizing evaporative cooling effects. You could call them swamp coolers, evaporative coolers, but basically I'm utilizing the heat from the Bitcoin miner and the airflow, which is from my tests here, showing that the air coming out of that miner is both warm and not very humid. And so that's a perfect condition in order to evaporate some water. Now, because I'm working with a small space, I needed to have a way to evaporate the water in a very dense form. And so what I found was there's these systems that use this clay called zeolite. Zeolite has a high surface area. And so actually when you pour water on this dry zeolite, it absorbs the water so quickly that it actually boils the water. So that suggests that there's a huge amount of surface area in there for evaporation. And so when you're evaporating the water off of the zeolite clay, one side is hot and then the other side of the clay is cold. And so the concept here is that I line a radiator with clay and blow the hot air. I line the radiator with moist clay, blow the hot air from the Bitcoin miner past that clay, exchange so that the clay is evaporating the water, creating a cooling effect against the radiator. I then pump that cooled water into a second radiator, which I blow a fan against to remove some heat and humidity from the room, move that heat back into the water and recirculate it. And so this initial test proved to me it was a positive result in that there was some cooling effect going on. Obviously, everything is outside and in the sun. And I've done successive tests that in indoor spaces, which have yielded continued further positive results. But at the scale that I'm working at, the cooling effect is fairly insignificant. If you're trying to cool like a living room or something, you'd need to add a lot more radiators or a lot more clay. And maybe even a second miner or something like that. But the idea is that I've got a miner running in my garage right now, not utilizing any of the heat. Yeah, go ahead and play the video. And so I figured if I'm just throwing that heat away in the summertime here, why not recapture at least some of it and utilize that to help cool and air condition my space. And so you can see here, I'm looking at the miner itself. I've got a temperature reading of the air coming into that temperature reading is the air coming out of the exhaust after it hits the clay. That other temperature reading is the air coming directly out of the miner. And so what's going on here is there's water coming into that radiator, and this is without the clay. This was just a baseline test to show what was going on without any evaporative effect. And then as I get on through the video, you'll see once I add the clay, what happens. I guess this video is about 6 minutes. Maybe we don't even need to watch all of it to get the general idea here. But to the right of the miner, you can see a fan and a second radiator. And so that's the idea of pushing that heat into the radiator, cooling the water or heating the water back up after it's been cooled, exchanging that heat and yep.
Oh, are you still there, Rob?
Yeah, I'm just trying to make sense of how to effectively talk about this while we're watching it, because a lot of what I'm saying here in the video is not really totally relevant.
I got you.
I was able to get a several degree temperature change in just 1 hour of running this with a small tank of water. I've since done successive tests with the larger 5-gallon tank of water. I've tried a couple different radiators, adding multiple radiators to that enclosure there. And so the results are positive. Basically, the idea is that, if you can, this is a fairly simple way to do it. There are more complicated ways to accomplish the same thing. If you put this wet clay under vacuum, you can enhance that cooling effect even more. But this was just the easiest way I could quickly showcase the concept and prove that, you can apply this Bitcoin mining heat to systems that are already evaporative coolers. And like I said, if you're already hashing and you need to do something with that, if you want to get extra value out of that heat, now you have an option of potentially adding some cooling effect to your space. You can expand this, and like I said, if you put it under a vacuum, and you can see the temperatures here, that when I pour the water on that clay, get extremely hot. There's steam coming off of it. It's boiling that water. So you could create potentially a freezer, a refrigerator, all sorts of things. And back to like the one of the honorable mentions with Dane in the hash rate house. So his system has to dump, but most likely is dumping some heat that's not being utilized through a dry cooler. And so you could take the same concept, build a clay lined radiator that goes up against that dry cooler, and accomplish the same effect without utilizing the airflow of the miner itself. You can have your miners in an immersion system. And this is where I'm going here at the homestead. I've have all sorts of Bitcoin mining heat reuse cases, but each place has its own miner and its own system. I'd like to move towards a system where I've got one central boiler and I'm moving the heat all different places and ultimately dump extra heat through this dry cooler. If I could make an attachment, the radiator lined with clay, now I can accomplish some heat recovery, heat reuse in the form of cooling in this evaporative cooling effect. So that's essentially what the project is trying to showcase here, is that this evaporative cooling effect is the easiest low-hanging fruit to do some sort of air conditioning, some sort of cooling, utilizing the airflow and the heat from a Bitcoin miner. Do you have any questions?
Yeah, where do I get that crazy clay?
So that's available on Amazon. Actually, I was able to order a 10-pound bag. It's very accessible. The trick is that I'm right now, I've just been placing the clay on the radiator. So that's why I have to lay the radiator horizontally, so the clay stays in place. But the trick is figuring out the best way to adhere the clay to the radiator, so then you can change the orientation to be a little bit more beneficial. And
I bet you could like custom build a part. Like some of the people have been using KiCad for their projects. I wonder if that you could like custom design a part to like hold that clay in place against the radiator.
Yeah, and it's tricky because there's like a sweet spot I found too with how thick the layer of clay is. You basically want it, if there's too much, then the cooling doesn't actually make its way to the radiator and cool the water down. And if it's not enough, then you're starting to actually heat the radiator up with the heat from the Bitcoin miner. And so this is obviously there's going to be many more iterations on this because I want to finish this project to utilize it for my own self here at the homestead. But yeah, there's a lot more playing around to do. But from this initial test, this proof of concept, I've seen enough results to continue to move forward with it and continue to refine it and iterate.
That's awesome. Thanks so much for sharing. This is a really incredible proof of concept. You got a comment in the chat from Maru. This is such a cool project. Hope we get more miners in the summer. I could say, yeah, I would love to have one of these in my house because here in Georgia, we definitely need the air conditioning more than we need the winter heating.
Yeah, it's good for everyone. You know, if you got a cold climate, it eventually gets warm, and you got to turn the miners off. And hopefully, if this works, you know, and is viable enough, you can now keep running, keep hashing all year.
Yeah, that's awesome. Thanks, Rev. Okay, I'm going to go ahead and turn it now over to OTB. I'm going to remove you and add OTB. Hey, welcome.
Here, so let's see, present my screen. Okay. All right, awesome. So, can everyone see this presentation?
We can see it.
Awesome. So this is a project that I worked with an individual named Cyber. It's called the BitSat, or the CubeSat Bitcoin Miner. And here's the basic problem. Bitcoin mining using solar energy is subject to intermittent sunlight, disrupted by cloudy skies, the nighttime, and the atmosphere. You can imagine, if I'm trying to mine Bitcoin using a solar panel, the sun's only up certain times of the day. And once it gets closer to the winter time, that amount of sun time goes down by a significant margin. Launching a satellite into space is expensive. And I'll suggest a way that Bitcoin mining can help alleviate that. But the last problem is Bitcoin mining is geography constrained. It's whoever has access to the lowest cost energy is going to have the biggest advantage to mine the Bitcoins. And a lot of times that's constrained to the areas with very accessible geothermal energy, places like Iceland or El Salvador, where they can basically get all their energy for free without having to pay anything. That's why a lot of people use the sun, because it's available anywhere, but it's not 24/7. And so this is the idea Cyber and I came up with, the idea of a CubeSat Bitcoin miner. In space, there's potentially infinite amount of sunlight. Some minor nuances to that. There's roughly about 72 minutes per day where there's no sunlight, but we do have something that we've accounted for to address that. The Bitcoin mining aspect of the CubeSat, in addition to having the benefits of a CubeSat, there's a lot of nifty things you can do with a satellite in space, but the fact that it can generate Bitcoins can offset the cost of the launch. Space expeditions, launching anything into space is notoriously expensive. And so what better way to offset the cost of that than by mining Bitcoin? It just seems like a win-win. We get a satellite up there, we can offset the cost, and then we have the benefits of something in space that we can use. And then lastly, anyone, anywhere in the world can launch a satellite into space, in theory. I think the cost and the barrier of entry to space communication, space access is going lower and lower over time. And so I think this is a perfect time to really start considering personalized satellites that people can put into space. We have a Bitcoin miner in space. You can launch it from anywhere in the world. there's not a lot of places where access to energy is available, so why not leverage the space above our heads? There's plenty of space up there. If you're living in an extremely rural community, all of a sudden now you have access to essentially the power of the sun and power of Bitcoin mining to bring some money to your local communities. Here are some constraints that we're working with. The design of the CubeSat miner has to be able to withstand the harshness of space. I think this is something that it's going to take a long time to really figure out all the details of that. Like building a space-capable satellite in a month's time is ambitious to say the least, unless there was already work going into it beforehand. But I think we've got a good start, and I'm happy to show that off once we get to a couple slides further down. Materials must be lightweight and consume little energy other than the Bitcoin mining. The basic idea here is we wanted to make something that doesn't weigh a whole lot when it comes to launching something in space. The weight of the object is a big factor, so we wanted to keep it very minimal weight. And other things include the communications between the satellite and home base. It's going to be in space, so we need a way to contact the Bitcoin miner from wherever we're located. So the initial design that we came up with, a 1U CubeSat. 1U is 10 centimeter by 10 centimeter by 10 centimeter cubic volume frame. That's based on the CubeSat Design Principles Handbook that was developed by the Polytechnic San Luis Obispo University here in California. And that defines just some general standards for how you actually create a CubeSat frame. Me and Cyber settled on a Raspberry Pi Zero for the main CPU board that will act as the orchestrator of all the different peripherals that are interconnected with each other. And Raspberry Pi Zero is very accessible and draws very little power, so it's great. Plenty of power for the CubeAxe, which is a bit axe that we repurposed for this CubeSat miner. A mobile radio. Mobile is long-range radio. It's an inexpensive radio device that we can use, at least for prototyping. I think once we go into a more official production mode, we'll have to figure out a better means of communication. But for the sake of just this hackathon, we thought that this was very appropriate. Solar panels for the energy, and a battery backup system for when the system isn't getting direct sunlight. And here's a lot of the components. This is the components that Cyber had collected. Cyber is still working on the solar panel part of it, so we won't be demoing that. But here's the basic schematic. We have 4 solar panels. It goes into a buck converter that goes into a battery management system, goes into the battery pack, we have another buck converter, and that gets plugged into the Raspberry Pi. The bit axe gets plugged in over USB, and we still have to figure out all the details of how this gets integrated together software-wise, but here's a 1U frame for reference. It's 10 centimeter by 10 centimeter by 10 centimeter. I have it here with me right now. I don't know how well you're able to see it right now that I'm sharing my screen, but this is a Raspberry Pi that I've got connected. It has a Raspberry Pi camera. It's currently turned on, and we wanted to stick with the design that was already existed, just to get a feel for how big this thing is. And so I 3D printed this at work just to get started on the work. And here's a little demo of the Raspberry Pi Bitcoin miner working. So I don't have access to a BitAxe right now, so I settled on mining with the Raspberry Pi itself, using the CPUs to mine. As you can imagine, it's not particularly powerful. Here's a console of me. I'm currently inside remotely my Raspberry Pi, and it's running BFG Miner. It's a Bitcoin miner developed by Bitcoin developer Deshaun for CPU mining in addition to GPU and ASIC mining. And it's running Alpine Linux. Alpine Linux is a Linux distro known for being very lightweight and preferred for small embeddable devices. And so I compiled it on Alpine Linux, got the miner running. To my surprise, it actually worked. And so it's pretty cool to see it running. I've never kind of worked with Bitcoin mining software before, so it was a fun little challenge to try and get this up and running, especially in a headless environment. So the impact of this device, it lowers the cost of satellite launches by mining Bitcoin. We mine the Bitcoin offsets the costs of launching it into space. Over time, it could potentially become profitable. It improves the security of the network by detethering hash rate from geography, further decentralizing mining. The fact that you can mine Bitcoin in space and launch it into space from anywhere in the world, I think, will be beneficial for the entire Bitcoin network long term as time goes on. And low cost and simple build means anyone can participate in Bitcoin mining. This was a little low cost. It's expensive to launch things into space, but the idea here is as that barrier to entry goes down, we want to be building the actual CubeSat itself hardware-wise as inexpensive as possible. And some future plans. So these are just some long-term ambitions because this is like pre-prototype even. Like this is like super early stages. We haven't even integrated all the technologies. Not even at the MVP stage yet. But some ideas like Saber and I have designed a space-ready one-new CubeSat chassis. Some full disclosures: the 3D printable frame that's in the GitHub repository is one that I had found on Thingiverse. The license for it is Creative Commons share alike, non-commercial. So we're not planning on using this frame in a commercial setting. We have to do a complete redesign of a frame, and I have some ideas already. There's some assembly modifications that I would want to make it add to this chassis to make it easier to put together. And I think it would make it much more rigid. Obviously, if it were made from metal, it would make it super sturdy. Cyber had the idea of a custom BitSat OS for tighter integration. We want to customize the software running on the device to be specific to the device. We'd open source that OS so that anyone can download and run it on their hardware. A custom PCB design incorporating LoRa, the Raspberry Pi 02W, and the BitAxe into one board. Maybe we have separate boards, honestly, for the BitAxe and the main controller board. We found someone online that had made a CubeSat simulator device leveraging the same frame. And so that can potentially be used to simulate the situations that this CubeSat would be in. And they have custom PCB designs, so that's kind of where I got that idea. And then lastly, I think the most exciting is intergalactic Bitcoin mining and node communication. There seems to be this future plan where humanity will go into space and will start colonizing different planets. And in that case, how is Bitcoin going to work in an intergalactic setting? If we have people on Mars and I'm trying to send someone some of my Bitcoin, some of my sats, how's it going to reach them? How are we going to mine them? And so I'm thinking if we have nodes in space, potentially we can use these nodes as Bitcoin mining bridges to connect our disparate intergalactic colonies with each other. But that's very far off into the future. But so that's the presentation I got there for the BitSat. Hope you enjoyed. Thanks so much.
Awesome. Thanks for submitting. Thanks for sharing all that. Have you one frequent comment I've heard from people is like what to do like with like latency, like when the satellite goes around the other side of Earth. Have you had any thoughts about like solving that issue?
If we have people, assuming that this starts to pick up like a network effect, and we have a bunch of people around the world that are all launching this, the idea would be, well, we can create a mining pool that connects all the disparate BitSat miners together, and everyone can start connecting to the nodes and offer that kind of communication to the satellite grid, essentially. And so we can kind of distribute that load across multiple users in the network. Potentially that can help, but there's going to be a lot of testing. Honestly, this is just like,
You could almost have like a mesh network of mining satellites that can all propagate blocks to each other.
Yeah, I think the most important is we make this, it has to be open source. We don't want to make it so only one entity is controlling the ability to connect to these nodes. Everyone has to be able to make it work, I think. But that's a lot of thinking through how that works still. But yeah, exciting stuff.
Yeah, exciting. If we can figure out 11-dimensional geometry, then we can make a SOFON like in the three-body problem, and we could have a SOFON that propagates blocks between different planets.
We use lattice structure cryptography to ensure the quantum space computers don't corrupt our satellite grid.
Exactly, yeah. Awesome. Thank you so much for sharing, OTB.
Yeah, thank you so much.
I have a question as well. If we...
Yeah, hey, Raghav.
Hey, sorry. Like I'm in a car, but that's a cool project. I wanted to ask a question about it. So, did you look into what it would take for like radiation shielding the ASICs? Because you don't want flipping cosmic rays. And I think even more importantly, did you look at like how you would cool the ASICs in orbit? Because like there's no air there, so and miners generate a lot of heat. So, did you look into the heat management aspect of it?
Yeah, so there's two things. So first, the heat. There's extreme temperatures in space, so I'm not too worried about when it gets super cold, unless it's going to affect the quality of the main board itself. For extreme heats, that's one of the challenging parts. We haven't quite figured out the details of how we manage the extreme heat environments in space. And for radiation, we're going to need some type of shielding. These are good questions. We haven't got to that yet. Thank you, Rudolph.
Cool, thanks. Cool project, so let's keep working at it.
Absolutely. Thanks so much.
Hey, Stephen, you're muted.
Sorry about that. Thanks. Cyber also commented in the chat. We did discuss Peltier modules for the heating in regards to the BitSet project. All right, Adi, you're up now with PCX. Would you like to share a screen or a presentation with us?
Yep, just like setting it up.
All right, let's see. There we go. All righty. It's all yours.
So, hi guys, my name is Adi. I'm actually a student at Binghamton University. So, it was, I had this great opportunity to be in this hackathon, to be a part of it. So, my idea was like a PCX, it's a PCI based, like a Bitcoin miner, where you like put it in your computer and start mining. It's basically like a replacement for a graphics card, which uses ASIC chips. So my problem statement is like mainly like the traditional miners are like very bulky, opaque, they lack transparency. The many corporate companies like don't expose like how they work. People need to like reverse engineer them like in order to know like how to like work with the chips, how to like mod them or anything else. So another thing is that hobbyists cannot easily like integrate mining hardware into like their desktop systems. So another thing is that these big miners are mostly like very costly and hard to afford by many people, and they need like a very professional setup, like a mining farm to mine these. So my idea was to make like a mini version of it, which plugs into your graphics card slot, and and you can like start mining it. So I found that there's like demand for like very compact plug and play open hardware like mining solutions. So I found out that BitX like follows like this comes under this problem statement where like there's like demand for compact thing. So I took BitX as a reference and made my own mini version of the miner. So introducing PCX, it's a PCI X4, it's a 4-lane based miner board, which plugs in directly into your desktop or PC or GPU mining rigs. So I've used like 12 BM1370 ASIC chips from Antminer S21 Pros. So these chips like have an average hash rate around 1 to 1.4 terahashes each, and I use a 6-phase buck converter with very high current capacity to control like all to provide enough current to all the chips and to have like an efficient power delivery. My estimated hash rate is around 14.4 terahashes at 200 watts of current draw. So as you can see, this is the spot where all the ASIC chips are going to be there. These are all like the other components. This is going to be like a buck converter zone. This is my basic design for this. I haven't like still like finished it. So my hardware architecture is like basically using a standard PCI slot. I didn't go with the X1 because like the slot like very flimsy. I don't want like people like destroying their miners by like plugging them out or plugging them into their slots. So I went with the X4 uh, slot because it is like kind of thick and it is like more stronger than X1. And I used like 12 1370 chips, which are like daisy chained. And I used like basic stuff. And I used like UART header, which is going to be easy for people like debug. So this miner is basically gonna show up as a COM port in your computer, and you could like run a CG miner or a BFG miner or BMM miner in your background, like to control this. So I haven't like still like worked on software. It's gonna be like a future thing, and white matters. So I wanted to be like plug and play solution, affordable path for hobbyists and small scale miners. I want open source community to like also be part of it. So my basic roadmap is going to be like finish designing the hardware, publish a BOM, and get like a prototype done, and continue with the firmware development. And I also like want the community test feedback because I want this to be like a really good product, well tested, suitable for all environment and climate testing. This was my main thing, and also like build a multi-board and a thermal scaling solution. So because I thought of initially using like big heat sinks, which were like I thought it was like going to make the miner way too heavy and bulky. So I thought of like making my own like custom water block to cool all the 12 ASIC chips. And that's it. Thank you. And here's a QR code for my GitHub repo. Any questions?
Awesome. Thank you. Yeah. Could you talk a little bit more about what you had in mind for cooling? I know a lot of times when I, like in a gaming PC with like a graphics card that goes in the PCI slot, a lot of times nowadays I would plug in like a water cooling radiator that hooks up onto the front. But I know with like multiple mining chips on there, that might get challenging with the number of chips. So do you have any ideas about cooling?
So first, I thought of like using like a really big heatsink like from 5090 for like a founder session because like they're like really bulky and they dissipate a lot of heat better and they give you like a kind of a good form factor. But I found out that they were like are not viable for my solution because like my whole chip structure is going to be on the end of the miner because like they're going to be like right here if you can see my mouse cursor. They're going to be like in the end, so I couldn't like attach the heatsink to it. I thought like it's going to be like impossible to attach the heatsink. So I thought of another solution which is going to be like water cooling. So we could basically make our own custom water blocks which could fit like all the 12 chips and cool the buck converters very efficiently. You could like attach it to your computers like a water cooling loop, or you could like attach it to an external radiator. Maybe you could even heat your some water with it, or heat your room with it. Yeah, that's my idea for like cooling all the 12 chips.
Very cool. Yeah, one thing I think that's interesting about this is I've heard a lot of talk over the past couple months about people trying to build custom control boards with Raspberry Pis. Like I think Scott mentioned something about it on one of his live streams, and I think I heard somebody talking about another project at a conference for using Raspberry Pis for control boards. But one thing we've seen, I know this has impacted, at least for a while, impacted projects like SeedSigner, is the supply chain issues around Raspberry Pis, and if they're if you can find them, if there's enough of them to go around. So one thing that's kind of interesting about just making something that can plug into a PCI board is that in theory, you might be able to use any kind of motherboard, like in place of the control board, like any kind of standard Intel or AMD based motherboard, you might be able to use that to control, Bitcoin mining ASICs with, as opposed to relying on the Raspberry Pi platform.
Yeah. So, I thought of like what I had in mind was my target audience was going to be gamers, introducing them to like mining. And I also like thought of, why not, use these for GPU mining rigs also. People, this could like, bring like an open source product to a commercially large scale market. And it's going to like be like better for both, It's going to like
Yeah.
decentralize mining, and it's going to like support GPU miners also.
Yeah, because I'm sure there are still people with GPU mining rigs out there, and so they could take out the GPUs and put these in, kind of chipsets into their GPU rigs. So awesome, Adi. Great project. Thank you for sharing.
Thank you.
Okay, I'm going to go ahead and move us on to our next one. And we have, so Eric was one of our finalists with Minor League Miners. He was not able to make it today, unfortunately, but I'm going to show off his submission video for him. So give me just a second and I'll get that screen set up. Okay. I think this should be the one right here. And oops, let me redo that one more time and just make sure I appropriately hooked up the audio. Also sure. Yeah, that looks right. Okay, so similar to the other ones, we're gonna you should hear Eric narrating his project here. If you don't, please comment in the chat, and I'll fix the situation.
Hey everyone, my name is Eric, and I'm going to be sharing with you the project that I worked on for the Battle of the Mind Hackers Hackathon. I am specifically focused on the Hash League track, and I'm working on a project called Minor League Miners. So what is my project? It's called Minor League Miners. And the problem that we're trying to solve is a way to incentivize people that are small miners, people that are running 1 or 2 bitaxes, to compete on Hash League. Right now, we're looking at Hash League as it exists today. The top 3 spots are controlled by people who have, at the minimum, a couple bitaxes, because you could see that spot number 3 is 7.43 terahashes. So if you're someone who just has 1 little bitax, you're never going to be able to basically compete, in the sense where you're never going to be in the top 3, because it's the same 3 pools that have managed to get everyone together to have the highest hash rate. So if you're someone who doesn't have a community, or you're just a solo miner, I thought, what can we do to create a parallel system within Hash League to make it fun for these people to compete? So I came up with the idea of Minor League Miners. This is a separate category, or a separate competition for people that are running just 1 or 2 bitaxes. So maybe someone that is under 2.5 terahashes, where they're competing on a leaderboard, but instead of just competing based on the amount of hash rate, they're competing on the best difficulty that they hit within a 1 week or any specified time window. So what I did was put together a UI and a backend that is in addition to Hash League that helps display this. So let's start with the bottom of the stack. At the very, very bottom, I am running, because I am traveling on the go, I do not have my full unpruned node with me, but I was able to set up a RegMiner test network using Polar with this Bitcoin RPC information that's running, and it's doing an auto mine every 30 seconds where it's sending in blocks. So I have this information for the node, and I have it plugged into my own local public pool instance. We can see here the same Bitcoin RPC information loaded here. It's currently running, because at the bottom of the test network, we see that there's new block height change, and it's currently running. Excellent. So we have a public pool instance running. That's step 1. Step 2 is plugging in this public pool into a fork or a new version of Hash League, where these miners are shown separately and the best difficulty is shown separately. So when we run this public pool instance here, we could see this is the API that you get from the local public pool instance. And if we scroll down here, we see the user agents. So these are currently the active miners that are pointing to the public pool. So we could see that we have one user agent that's running, which is the BitX that is located right here. I have a fan next to it because it's a very hot European summer right now, and they don't turn on the AC, and this is the only way that I can keep the miner from overheating. But nonetheless, we're still mining from hotels in the European heat wave, a trillion hashes a second. They can't stop us. So we're live, we're running. This miner is being pointed to the pool. And we could see that from the API, we get the best difficulty, 20,066 point large number. And if I hold my BitX here, and I'm not sure if you could see here, but that is inaccurate because I have not refreshed my screen in a while. The actual best difficulty looks like it's 3.64 million. So if this is all configured correctly, when I refresh this information, I should see the best difficulty update to what's being displayed on my BitX. So I'm going to hit refresh. I'm going to go here, scroll down to user agents, and I should see, boom, that matches 3644, whatever. Yep, 3.64 million best difficulty on the BitX. So we know that this is live, running in real time. The public pool instance is pulling this data in real time. Excellent. So now the next thing is, this is not necessarily part of minor league miners, but I also built my own UI for the public pool. So the API and the information that you saw, this is it being displayed locally in a UI. Let's just call it Eric's pool. And we can see here, there's currently one online device with the best difficulty of 20.07K. But again, I haven't yet refreshed this to update to the 3.64 million difficulty. So if I refresh this, that should update, boom, and it did. Excellent. So next comes the actual integration with Hashlead. How did I do that? I relied heavily on Cursor. And what I did was I created a new hook called use best difficulty, which we can see being displayed here. And what this does is it fetches the best difficulty from the user agents right here. And then, so we can see user agents best difficulty. So this hook is basically fetching that information, and it's displaying the user agents and the best difficulty. And it's collecting that information. And then on home, I also created a new component called Top Minor League Panel. And this is an actual component that will display the best difficulty from the hook in a tile component. So I created this component here called Top Minor League Panel. And then under home, I added that component. Where is it? Here it is. Top Minor League Panel here. I added it there. And I'm also importing the use best difficulty hook that I showed earlier here in the header. Thankfully, with AI, I was able to vibe code all this. I'm more in the world of product design. I'm learning front end and development, but nonetheless, it works. So what does that actually look like? So I am also running my own version of Hashlead, which I will include in the GitHub link in the submission. I recommend you look at the latest branch, which I will. I forgot what I called it. I think it's called like SDB node or something. SBD pool. Look in that branch. I will push the commits as soon as this video is done. So I am running that, and that looks like this. I had to disable the map because there was a pop-up every second that it couldn't pull up the map from OpenGL. So I just disabled that temporarily. But we could see here that it's actually showing the live miners that are connected because it's pulling this information, this API from the hook here. The use best difficulty hook is being displayed in the Top Minor League Panel component, which is being displayed in the home page here. So on this local version of Hashlead, we now have the Minor League Miners leaderboard live. And I'm not sure if since the time that I mentioned the last difficulty, if we've hit a new difficulty, probably not, but let's refresh just to see. And no, we haven't. But since it's pulling and refreshing I actually have it set up also, I should probably mention, to refresh every 10 seconds. Yeah, every 10 seconds, there's a refresh interval. Yeah, here it is. So it should be refreshing every 10 seconds and displaying this information, which is probably not efficient for a production environment. You might want to use like a webhook or something like that to pull the data. But for my local environment, that seems fine. So this is Minor League Miners. It's this panel here where it shows the miners that are competing. And instead of the hash rate, like it shows in the traditional hash league where we're going by hash rate, on Minor League Miners, we're just ranking people based on best difficulty. So that is the project. And again, the goals are to make a competition or some other way for small miners under a certain terahash where you just have 1 or 2 Bitcoiners to compete on best difficulty and make it fun. So this is my submission. This is my project. I've had a lot of fun doing this. I've learned a lot. I come from product design. I do not come from development, but I was able to do all this, to create a best difficulty component and then fetch API info and go in and actually look at the API JSON file and understand like a user agent, and the best difficulty is, you know, the information that's being pulled from there, and then being able to string that together into the top minor leagues panel, so it's pulling and displaying that information and styled it a little bit, then putting it on home. Yeah, basically what I did was new to me, because I'm a product designer, I'm a Figma person, I'm a pixel pusher, but I'm learning, and I had a lot of fun doing this. And in the future, I think that with collaboration, we can make it better. Maybe some of this code is sloppy. Maybe it's inefficient. Maybe it's not the best way to do things. I would love to see more incentives for the minor league miner guys. Initially, in my original project, I wanted to create some kind of payment pool where people submitted payments and things like that. Outside of scope for this submission, but here I am. I'm a little bit over 10 minutes, so I'll cap the video here. Thank you to all the organizers for hosting this competition, inspiring people to contribute to mining. I'm having a lot of fun running my BitAxe. I bring it with me everywhere, in hotels, because I like the BitAxe, and I like the mining. I love the Bitcoin. And yep, thank you for the opportunity, and I wish you all the best in all your future hackathon endeavors. Take care.
All right. Thanks for the submission, Eric. And I just want to go ahead and, highlight there that, Eric was incredibly open with, everything that he was working on. If you notice, he's not afraid to, show off areas where he has a knowledge gap and where he encountered challenges and had to overcome them. So I just wanted to highlight that for everyone as a really good example of working in public and getting feedback on unfinished work. Even though his project was functional all along the way, he was very interested in sharing his unfinished work. I also want to highlight real quickly too another one. So let's see if I can present very briefly here. Let's see. I'll just share. What am I doing? I'm going to share. There we go. So this was a submission. Oh, not really a submission, but this was from Jade Aug in the Discord, and didn't have time to finish up or do a video presentation. Wanted to post it here. This was for the energy track, made an infographic about mining Bitcoin off grid using solar energy. So, like I said, as always, a reminder: don't worry about finishing it. Don't worry about being complete, being done, being complete. These are just illusions. Reality doesn't actually work that way. So always submit whatever you have during a hackathon. Always share what you're working on openly. It's never going to be perfect. But this was an infographic that they designed about mining, off-grid hashing using solar energy. So great work. Thank you for the After Effects submission. Next time, actually submit it. All right, cool. Let's go to some other stuff. So we're going to take a very brief break here and just figure out some things on our end, and then we are going to do an award ceremony. So just hang tight, everyone. This should take about 5 minutes or less. All right, we're back, everybody. Okay, so we've reached the end of this hackathon. Thanks, everybody, for participating. We're going to go ahead and announce our prizes and awards right now. Moment everybody's been waiting for. Okay. So, this was definitely a difficult call, but the judges have decided. So for our first prize, which is our software track prize, this goes to Minor League Miners. like I was mentioning before, Eric did a great job of working in public. Also, we didn't get as many software submissions as I would have thought. I think people were more interested in the hardware and the energy track ones. But Eric did a great job of working in public on this one. Had an idea for taking an existing project and improving on it, and executed it very, very well. Reached out for help when he needed it, and yeah, like I said, delivered a working project. So everybody was very impressed with minor league miners. See, Eric's joining us in the chat. Congratulations, Eric. All right, we're going to move on to the next one here. On the hardware side, this prize goes to PCAX. I'll add Adi in case you would like to say anything, but everyone, this was, impressed with the fact that this looked like something that could actually function if you, put this in a PC. I know you still have to do some testing and make the actual board, but you've shared your work on the Discord along the way, delivered actual CAD files in a GitHub repo. So great work, Adi.
Yeah, thanks for the opportunity.
Cool. Where are you going to take the project next?
I'm gonna work on it. Make it like a working, make a working product out of it. That's my main goal right now. It's like it's been like all my like side projects, so I've been like focusing like more on my studies right now. So it's gonna like take a bit of time, but I'll do it as soon as possible.
So, awesome. Well, congratulations, Adi.
Thank you.
All right. Now moving on to our next one. This is the energy track. On this one, we have the Bitcoin mining air conditioner with Rev Hodl. Rev, congratulations. Everyone is very impressed that, well, I think everyone was just really blown away because this was just a really bizarre idea that you could take something as hot as a Bitcoin miner and actually use it to make cold air with. I think we've all heard the narrative about heating your home with a Bitcoin miner in the winter, time and time again. And this just really kind of flipped the narrative around that you could actually might be able to use it to cool your home. And you demonstrated a proof of concept that it actually can work.
Thank you. Yes. It's really exciting because, now that people see that this option is available, I just literally hack things together here at the homestead. And, as you saw with Dane's example of the hot water heater and Travis's example with the hot water heater, they're able to take some actual engineering prowess and make these things into something that really functions well. And so I hope to inspire people by doing stuff like this to take it to the next level. The whole point, right, of this hackathon is to expand the decentralization of mining and make it so that the average pleb can feel like they can do something. They can run some hash, they can own and operate some hash, and this is good for Bitcoin. And selfishly, I really want to just turn my air conditioner off and just run my miners anyways.
Awesome. Sounds like a great idea. Well, thank you so much. Congratulations.
Thank you.
All right, now we have our sponsor challenges over here. Our sponsor challenge was for Hash League, goes to minor league miners. This was actually, I have not reviewed, the code line by line. Need to, review it before we merge it. It looks to me like an actual working addition. I think it's a great. It's the kind of thing that we could feasibly merge into Hash League and start using. And I also think that it's a great addition. It adds another little way to play the game. In addition to forming your own community mining pools, you can get sort of individual recognition as well. So congratulations, Eric.
Oh, thanks a lot. I'm thrilled that it was so well received, and most importantly, it was fun. I started off with I think I mentioned that the idea initially came from me and a friend texting each other our best difficulty. So I kind of had that real world experience that this best difficulty thing was fun. And I'm glad other people felt that way. And yeah, I hope that we can in the future, we can jam on it, collaborate, and yeah, just figure out a way to make this best difficulty gaming thing a little bit more fun and interesting. Do you think that this is something that you would like to put in Hash League?
Yeah, I think so. Yeah, I just need to it's just a logistical thing of need to do some PR review on it and figure out exactly where we want it to live in the interface and all that.
Mhm.
But yeah, I think as just in terms of as a product feature, I think it's a great idea.
Sweet. Yeah, but yeah, man, what a blast this has been. Kind of exceeded my expectations. First time shipping code to this degree, and won't be my last. This has put some wind under my sails for shipping code.
Hey, designers are turning into product builders now. It's the way of the future.
Feels like it.
Yeah, awesome. Congratulations, Eric.
Thanks everyone.
And then let me just check something real quick. Okay. Our last one, the 256 Foundation, prize for the best use of 256 Foundation technology. Well, we're still waiting on them to deliberate. I thought that the 256 Foundation was a loosely organized group of hackers, getting shit done on the internet. But it turns out that it's a bureaucracy with many levels of management and middle management in order to get things done and make decisions. So they're going to hold a meeting later today to discuss this, the preliminary findings, and then they're going to hold another meeting on Monday morning at 9 o'clock to figure out what the subcommittee determined on Sunday. And then on Tuesday, they're going to make their final decision after it escalates up the chain of hierarchy to the highest levels of the 256 Foundation. But somebody is going to be getting a Bitcoin Park membership for a year. So unfortunately, I can't announce that one today. But anyways, so cool. I think that's about it. This was the Battle of the Mine Hackers. I'm just going to go ahead and bring up the homepage again as some nice background art. I thank everyone for participating and joining in this process. This was kind of an experiment. This was the first time ATL BitLab has put on a hackathon. So it was a new experience for those of us here at the lab. And this was also a new experience trying to do something involving Bitcoin mining for a hackathon. The first hackathon I know of where we've encouraged people to get their hands dirty with actual hardware and all of that. So, we look forward to, everyone's feedback on the event. We'd love to hear what you think went well about it, what you think didn't went well. Should we do it again? Should we do it again? If so, what should we do differently? So just, if you have comments, you can let us know on Discord or on X or Nostr or whatever. But otherwise, that concludes the Battle of the Mine Hackers here. So yeah, I just dropped everybody on stage, all of our finalists who are still in the chat. If anybody has any final comments that they'd like to say, otherwise we'll go ahead and wrap things up here.
Thank you for everything. And I really hope that you continue this because this kind of stuff's important, man, to keep people inspired, keep people realizing that, there are all kinds of what we're doing with Bitcoin is we're pioneers. This is uncharted territory, and there's a lot of stuff that hasn't been discovered yet, that hasn't been tried, and hackathons like these push the needle and move things forward. Thank you.
Thanks, Rev. All right. Well, thanks for showing up, everybody. Thanks for participating. Yeah, like I said, just spread the word. Keep on building with Bitcoin, everybody. And yeah, thanks again. Enjoy the rest of your day.